Okay, so we're still on line 22 for the well data, and this is part 284C3K30, and there's several videos, of course. They start with, actually that's the end of line 29, went to E, and now we're on line 30. Okay, so we're on to the next line. Sorry, within line 22 there's more than one line. Never mind, I'm confusing you. So the last several videos were all together, and I thought, oh, we'll see. Line 22f1fa19c3k30, Carbonyl Ligand bonding Metalloids clusters 5G Wow Seti. So there's the alien radio signal there with the numbers to go with it. August 14th, 2012 when I was doing this particular research, and today is November the 20th, 2012 when I'm filming it. So quotes from Wiki. Bridging carbonyls. The carbonyl ligand engages in a range of bonding modes in metal carbonyl dimers and clusters. In the most common bridging mode, the CO ligand bridges a pair of metals. This bonding mode is observed in the commonly available metal carbonyls. Okay, so there's the different codes there. In certain higher nuclearity clusters, CO bridges between 3 or even 4 metals. These ligands are denoted U3CO and U4CO. CO. Less common are bonding modes in which both C and O bond to the metal. So there it shows the different shapes and how they bond. Very interesting. This is quite the little design here. That's a structure of MO6CL14. That number there. I don't know how to read it. Metalloids in the periodic system. So this came up as well. It talks about boron, carbon, aluminum, silicon, arsenic. And a lot of these things that come up are mentioned in the videos. So, okay, so keyword metalloid clusters ligand freed. So the quote from Wiki is, in chemistry, a cluster is an ensemble of bound atoms intermediate in size between a molecule and a bulk solid. Clusters exist of diverse stoichiometries and nuclearities. For example, carbon and boron atoms form fullerene and borane clusters, respectively. Transition metals and main group metals form especially robust clusters. So this is going to be about transition metals, which is in the UFO design, right? So August 14th, my thoughts. The keywords bonding metal ligand bridges. Use the alloys and bridge them together. So these are my thoughts. You use the alloys and bridge them together to form an elastic, high temperature type of sheet metal that can bend easily, but is really strong, and high temperature doesn't make it heat up. It will stay cool. This will be used for the outer shell of the UFO Engineering Design. The heat shield does not separate from the ship. It stays lightweight, will not affect fuel formula calculations. So that shows that, and that shows that. Keywords CobaltCarbonyl, isomers of dicobalt octacarbonyl. So that shows that, some sort of rotation there. Iron-pentacarbonyl-Berry-mechanism. Quote Wiki, iron-pentacarbonyl exhibits only a single 13C-NMR signal owing to rapid exchange of the axial equatorial CO ligands by Berry pseudorotation. Okay, so that has something to do with something. I'm not sure. So thanks for watching. We'll go on to our next video.